All right, so what we're going to go over first is we're going to go over the ratios for the 6 trig functions. Ratios for 6 trig. Trig really is a short name for trigonometric, right? Trigonometric. Ratios, so really the ratios for the six trigonometric functions. You've dealt with the word functions in Algebra 2. A function is really something that when you have a specific input, it only gives you one output. Maybe you remember that functions pass the vertical line test. Does that sound familiar from algebra? Yeah. Functions pass the vertical line test, right? So these are the ratios for the 6 trigonometric functions. So I'm going to squeeze the word the in here, sorry. All right, so ratios. When you hear the word ratio, a ratio is really a proportion or a fraction, okay? So a ratio even has to do with the word rational numbers. Rational numbers are numbers that we can write as a ratio or a fraction. So an example would be 0.25, right? 0.25, also known as 25 over 100, also known as 1 over 4 when it's completely reduced. That's a ratio. Even repeating decimals, like 0.3 repeating. 0.3 repeating is really what as a fraction? 1 over 3. 0.6 repeating is really what as a fraction? 2 over 3. Now, these are the two common, I would say, repeating decimals that we tend to see a lot. But then what about if you had something like 0.17 repeating? Do you know how to change 0.17 repeating into a fraction? Do you know what the rule actually is for these? Okay, so ready? The rule is actually this. You take whatever number is repeating. In this case, the number 3 is what's repeating, right? You write that number down over, now you're going to put a 9 in the denominator, but if there's only one digit repeating, then you put 1 9 in the denominator. If there were 2 digits repeating, like this one, you're going to put 2 9s in the denominator, like a 9, 9. But 3 9s reduces to 1/3, right? In this case, the technical way to do it, I would get 6 is repeating, so 6 is going to go in my numerator, and it's going to go over what? 9, which reduces to 2/3. So yes, that 6 over 9 reduces to 2/3. So in this case, we have 2 digits repeating, which you normally, I feel like, don't see and memorize by heart. So I'm going to just take 17, the 2 digits that are repeating, and it just goes over 99. If it can reduce, you reduce it. If it can't, you don't. No big deal. And that's how you write a fraction from a repeating decimal or vice versa. And even if one more example, say I have 1, 2, 3 repeating. 1, 2, 3, 1, 2, 3, 1, 2, 3 over and over. As a fraction, what would I write? Yeah, 999, 3 9. So however many digits are repeating, that's just how many 9s go on bottom. So fun fact, fun little thing just to know on the side. So these are ratios. These are ratios that are repeating decimals. This is a ratio. If it's not repeating, do you remember what word we use for a decimal that's not repeating? It ends. It's a word. It starts with a T. What is it, Maria? Terminating, but yeah, terminal or yeah. So it terminates or it ends. It's a terminating decimal. Something like 5 is really a ratio because it's really 5 over 1. And these are all ratios. Trig functions. We have 6 of them, and they all represent different ratios of triangles. How many? And we use right triangles for this for right now. That's where it all begins. Okay, so just sealing this off over here. I'm going to draw a right triangle right over here. Arbitrary little example. There's my 90-degree angle. If I call this angle theta, theta is referring to this sweeping motion that happened from here to there. This is sort of like overlapping my x-axis. That's my initial side, and this one is what we call the terminal side. And this is what's swept out to create the angle. This is the angle, I call that one the Greek letter theta, right? Theta is the angle. We use that Greek letter to represent it. Now we have 3 sides that we address in this. One of the sides is going to be opposite from the angle. One is going to be the hypotenuse. And then we have a third one. So let's start with those 2. I have this side here, x, I'll call it, and y. Is one of these sides the opposite or the hypotenuse? One or the other, either opposite or hypotenuse? Y is opposite. Good. So you could leave it Y, or I could go over here and I could call it, I'm just going to use OPP, okay? Opposite. Which of the 2 remaining sides is the hypotenuse? This one? Okay, good. That's the hypotenuse, HYP. It's always across from the 90-degree angle. The 90-degree angle is always the biggest angle in a triangle because how many degrees are left for the whole triangle to share? Right? Because altogether it's 180. So if 2 angles have to split 90, then 90 is the biggest angle. That's the hypotenuse. What's the name of this remaining side? Good. ADJ, we abbreviate it. Adjacent. Okay. Now, if I have 3 different things and I want to make groups of 2, how many different ways can I match things up? I have 3 different things, hypotenuse, opposite, and adjacent. How many ways can I group them 2 at a time?
3.
Not just 3. If order matters, really 6. So I could either do adjacent with opposite or opposite with adjacent, right? Hypotenuse with opposite or opposite with hypotenuse. And then adjacent with hypotenuse or hypotenuse with adjacent, like depending if order matters or not. Well, if there's 6 ways to combine these, that's why there's 6 trig functions. They're each a different way to stack the ratio that we're dealing with over here. Who is the original trig function? Sine. The way you spell sine is what? S-I-N. But that's the abbreviation. What's the real word for sine? E, right? Sine. And then we abbreviate it S-I-N of theta. So we always put an angle there. Now you learned a phrase when you were probably in geometry. Again, what was that phrase? To help you remember your trig functions. Yep. So I'm going to do SOHCAHTOA. Now, obviously, like I said the other day, if you can't spell SOHCAHTOA, it's kind of useless, right? Like the whole point is for the spelling to help you out. What does SOH help us with for sine?
S for sine, O for opposite.
Exactly. So the sine is the opposite over the hypotenuse. Reduce your fractions all the time. Reduce. We don't use the word cancel. Canceling is like when something turns to 0. So 5 minus 5, those cancel and you get 0. But 5 divided by 5, those reduce and you get 1. Question? Always reduce. Always, always, always. Otherwise, it's too difficult for us to compare ratios. And also, like, a ratio of 30 over 40 and 3 over 4 creates the same angle because they both reduce to 3 over 4. So if I do 3 inches to 4 inches, or 30 inches to 40 inches, or 30 miles to 40 miles, that angle that I'm comparing is still the same measure for all of those triangles. It's exactly the same. So one thing is you want to make sure you reduce. There's another thing that we talked about when we were writing some of our answers. I told you have to do when you're dealing with your answers for this. What's that other thing we have to do? It's an R word, and you do it to the D word. Rationalize. Now think again. Here's ratio again. Rationalize the denominator. If you're not rational, what are you? Irrational. Irrational numbers cannot be written as a fraction. What's the only kinds of numbers that we cannot write as fractions? Well, one, they're called irrational. Sometimes we know them as numbers like pi. But what other numbers can we not write as decimals? Well, those aren't in the real numbers, but sure, imaginary numbers we could think of. Was there another word I heard? Radical, like radical 2, radical 3. I would skip radical 4, because that's 2. Radical 5. These are all gross, non-repeating, non-terminating decimal. These are irrational numbers. So when you rationalize a denominator, you're getting rid of the irrational thing. That's why it's called rationalizing it. When you rationalize with a person who is being irrational, right, you try to make them rational. Okay, we always got to do these things. If you don't, you will lose points on a question like this, okay? Next, that's sine. The next function that came from sine is cosine. The spelling is the same as sine, but with the co in front. The abbreviation is COS. And what's the ratio for cosine? Good. Adjacent over hypotenuse. Again, same rules apply. We have to reduce, and we have to rationalize the denominator, okay? After sine and cosine, the third one you learn in geometry is tangent. Spelling is tangent, just like when someone says, oh, I went off on a tangent, okay? The meanings are sort of connected right there. Abbreviation is tan, T-I-N, theta, and the ratio is? Good. Now, these have been our abbreviations we've been using since geometry, these little ratios right here. But we're going to see in the unit circle, because of the unit circle being so handy, where its radius is 1 unit, it makes our life a lot easier. We don't have to do our ratios as intensely. After tangent, I have sine, I have cosine. I have tangent, I have cotangent. They're buds, tangent and cotangent, sine and cosine, and then the other two. What's the abbreviation for cotangent? We had it in our notes a while back. Do you remember what the abbreviation was? I heard it? COT. Yeah, COT theta. And that ratio, it's actually, tangent and cotangent have a very complicated relationship. Not only are they co-functions with each other, like sine and cosine are co-functions, but they're also reciprocals of each other. What does reciprocal mean? Flip, right? So I always think like reciprocal, it's spelled like that. And then I think that's an R-E, refliprocal. Okay? Reciprocal or fliprocal. So those are tangent and cotangent. It's complicated. Not only are they co-functions, meaning the word co literally just goes in front of it, but they're also reciprocals. So what ratio is cotangent then if they're reciprocals?
Adjacent over opposite.
Good. Adjacent over opposite. Now I'm going to write with the highlighter. I know I used blue paper, which was probably a poor move on my part. But in yellow, I'm going to highlight reciprocal, refliprocal. Okay? And I'm going to kind of show some of the reciprocals with each other. One set of reciprocals, like we said, is tangent and cotangent. Okay? I'm going to have to keep changing the colors, so I'm going to like layer it up a bit. But we'll see a little at a time. So these are reciprocals, the same ratio, just flipped over. Now there are 2 new ratios we introduced after sine, cosine, tangent, cotangent. There's another one, and then the co of it. Cosecant is 1, so that's the co. And then the one before it, obviously, is right, secant. Okay, so those are the full words. Now, what's the abbreviation for secant? SEC. No reason not to use the first three letters. Now, secant, I'm going to kind of highlight again. So another layer of reciprocal, because I can't use yellow every time because then they'll all just be highlighted in yellow. Secant is reciprocal with which one? It's actually, yeah, so C goes with S, C goes with S. You know, like, don't group the S's together or the co's together. It's a little intensely weird. So this one is the reciprocal of that one right there. So what will secant's ratio be? Good. Hypotenuse over adjacent. Okay, so I'm going to do that one in pink as well. So I just know who is the reciprocal of who. All right. Done. And then next, I have cosecant. So there's only one bud left. So that's going to be reciprocal of sine. The abbreviation I heard, what was it? Good. We can't use COS because that's cosine. Now it's the reciprocal of sine. So what's the ratio? Hypotenuse over opposite. Good. Okay. So in these layers of highlighting over here, I have all of my reciprocals kind of paired off. So I do have some colored pens up there, I think, in that pocket. And in this jar here, I have colored pens. So if you wanted to color coordinate for yourself now, or if you look at the video later and you kind of use the video later to help you, you know, boost up your notes a little so you have like a good study guide for yourself so you know everything. I'll put it on, it's going to be on YouTube and I'll make a Google Classroom at the end of the period. My watch will go off when we have 10 minutes left, so I'll kind of set us up at that time. And it'll just be saved there.
You have 10 minutes.
When we have 10 minutes left.
When we have 10 minutes.
Yeah, my watch will vibrate, so I'll know.
Well, technically we have like more than 20 minutes.
Yeah, well, I know. My watch didn't vibrate yet. When my watch vibrates, I'll know. Yeah. Okay, so those are my ratios. Now, the unit circle, we said, comes in handy because, couple things. For one thing, angles go on forever. You can keep making angles bigger and bigger and bigger and bigger. It would be crazy to try to put them in a table because if you put it in a table, the table will have no bottom. Okay? So right over here, I'm going to just draw a quick little circle. So I gave you guys these little tape guys to trace, so I'll use one myself. So there's two of them around the classroom. So if you want one, help yourself there, grab it. So refreshing some of the unit circle. I know some people were struggling with it because you maybe were out or whatever. So I'm going to kind of try to figure out where the center is. I'm just going to draw my two axes. Oh, this. There's that and that. These represent my x and y axes. Yes, my x and y axes. Now, if this were graph paper, okay, if this were a piece of graph paper, it's the unit circle, again, because we said the radius is how big? It's 1 unit. So here's graph paper, right? The unit circle, if it were on graph paper, is that little. Can you really fit anything like detail-wise on this picture? No. Okay, look at like how little this thing is, right? Teeny tiny. So what I do is I just draw it pretty huge and you just make your own scale and that's it. So what ordered pair is this? 0, 0. Ordered pair, right? Pair implies 2. Now I'm not going to put everything on here yet. I'm going to go through, I'm going to put down all of the tick marks that I'm touching right here. And again, I'm color coordinating. There's a method to the madness. There's a reason why things go a certain place. So if I use, sorry, I'm just looking at what colors I'm dealing with here. Okay, so if I use orange right now, what did we say the starting point is for radians without looking at a unit circle? Starting though. We start at 0 and we go around and now it's 2 pi. What's halfway between 0 and 2 pi? Pi. Halfway between 0 and pi. So far so good. That's pi. That's pi over 2. Halfway between 0 and pi over 2? Pi over 4. Count by pi over 4. 1 pi over 4, 2 pi over 4. That makes this? 3 pi over 4. 4 pi over 4. Checkpoint. Next. 5 pi over 4. 6 pi over 4. Can you reduce 6 pi over 4 for me? 3 pi over 2. So it's still 6 pi over 4. If you want to leave everything over 4, knock yourself out. Reduce it later, okay? So it's 3 pi over 2. Then 7 pi over 4. And then this is 8 pi over 4. Checkpoint. Those are my radian measures of pi over 4. What did we say in degrees pi over 4 is? In degrees. Good. Pi over 4 is 45 degrees, right? Pi over 2, I'm just going to write some important ones on the side, is how many degrees? 90. Good. Pi is 180. Good. 3 pi over 2 is 270. And 2 pi is good. Another thing, when you're counting them around to go faster, count by 3s or count by 9s, whatever we're going around. So if this is 90, if you count by 9s, what's after 9 is? No, by 9s. Keep adding 9. 18, which is 180. Another 9? 270, right? 36, which is 360. And we could keep looping around. So after 360, again, would be 450, 540, 630, 720, and so on. Question? Not the kind of question I'm hoping for. Change this to your information, and then let me sign it. Okay, so those are the 45-degree increments. What increment do we count by also? 30 or pi over 6. Good. So I'm going to overlap. There is an overlap sometimes. If this is 1/6 of pi, can you see why this would be 1/6? If I go through with the yellow highlighter, and I'm slicing up the pi, which is the top half, do you see I make 6 slices? So that's 1/6 of pi. Okay, that's 1/6 of pi. If I keep counting around, I'm going to hit here. I do not overlap that orange one. Do not touch it. Then I overlap here, here, not the middle. None of the middle ones, okay? That one's good. Yes, yes, yes. Skipping the middle. This one, that one. Got it? Do you see everywhere I hit and where I didn't hit? By 6s, now we count. This is 1 pi over 6. This is 2 pi over 6, which reduces to what? Pi over 3. 3 pi over 6, checkpoint, because that's the same as pi over 2. 4 pi over 6, which is good. 5 pi over 6. 6 pi over 6, checkpoint. Here is 7 pi over 6. 8 pi over 6, which reduces to 4 pi over 3. 9 pi over 6, which is checkpoint, 3 pi over 2. Okay? 10 pi over 6 reduces to 5 pi over 3. I would say this spot, for some reason, right here, is the #1 mess up spot on the unit circle. Be careful. I don't know. You guys just mess this one up a lot, all students. I feel like it gets like you get tired of reducing or you over-reduce, you do weird things. This is one of the top places for mess up, so be careful there. That was 10 pi over 6, so what's this? 11 pi over 6, and then that's 12 pi over 6, aka 2 pi, checkpoint, beautiful, amazing. Okay, next, small, medium, large. The numbers that we came up with, I promise you, we derived them. They came from 30, 60, 90 triangles. Now, I could put 30 degrees in this angle, or I could change it to radians. These are radian measures. What did we say is the same as 30 degrees? What's the same as 30 degrees, sorry? Pi over 6. I could put pi over 6 there, right? Now, how long did we say the radius of this circle is? Do you see it's 1, right? Unit circle. So if that's 1, when you use the rules for a 30, 60, 90, or a pi over 6, pi over 3, pi over 2, that side will be 1/2, and that side will be radical 3 over 2. That's essentially my coordinates for an ordered pair. So what's the ordered pair of this point right here? You move over radical 3 over 2, and you move up how much? 1/2. And this is the hypotenuse, right? Which is 1. I'm going to write this ordered pair here. Radical 3 over 2, comma, 1/2. Now, this ordered pair, I'm highlighting this as nothing to do with the colors up top, okay? I'm going to highlight this in pink. I'm going to highlight the pink pi over 6 and the ordered pair. What other angles on here have the same ordered pair? The only thing that changes is the plus or minus sign. What other angles? Which ones? Go ahead. 5 pi over 6. What else?
The one, I think 4 pi over 3, or 7 pi over 6.
Yeah, so look, count it. 5 pi over 6, 6 pi over 6, 7 pi over 6, right? 7 pi over 6. What else?
11 pi.
Yes. These 4 spots. If I drew a light pink dotted rectangle right here, okay? That one, connecting to that one. Do you see it makes a perfect little rectangle right here? To there and to there. Do you see how they all move over the same amount of x, and they all move up or down the same amount of y? Okay? They're all moving up or down the same amount of x or the same amount of y. Comprende? Yes? So your coordinate point moves the same in each direction. So that's why these ordered pairs are going to be the same. But what I'm going to do, I don't want to write these ordered pairs on every single spot. It gets so crowded on this circle. Do you see that in pink? I know that they all go together. They're part of the same set. They're part of the same set. So I'm going to go over here in each quadrant. And all I'm going to do is I'm going to write down the signs, positives or negatives. Where's Jordan's seat? Behind Brandon? Yeah. I'm going to write down the signs, positives or negatives, in each quadrant for us, okay? In this quadrant, both numbers are, yeah, so I'm going to write positive, comma, positive. In this quadrant, what are the signs? Negative, comma, positive. Good. In this quadrant, what are they? Good. Negative, negative. And here, because you go right and then down. So if I asked you, what's the ordered pair here at 11 pi over 6? You would say positive square root of 3, comma, negative, exactly. Here, you would say negative radical 3 over 2. I think that said pi over 3. I meant to say rad 3 over 2, sorry. Here, negative rad 3 over 2, negative 1/2. Negative rad 3 over 2, positive 1/2. Got it? Okay. Positives and negatives, same ordered pair. I labeled it once here. The same will apply for these other places. Which other point in quadrant 1? This is quadrant 1. I'll even label the quadrants here. Quadrants are always Roman numerals, okay? Quadrant 1, this one's 2. This is 3. IV is 4. Okay. What other ordered pair or what other angle in quadrant 1 has very similar ordered pair? Pi over 3. The only difference is what? It's flipped around the other way. Your left and right and your up and down switch. So instead of moving over rad 3 over 2, that's how much you move up. If I cut this little triangle out and flipped it over, do you see it would be the same as this triangle here turned on its side, right? Do you guys see that? If I cut this triangle out, right here, cut this out, it would be the same as this triangle here. Do you agree with me? Thank you. Okay, so here, ordered pair is just the other way. 1/2, comma, radical. Good. And then if I were color coordinating, I'm going to take green, say, pi over 3 is this ordered pair. I know it's a little hard, the colors to see on here, but that's green right there. I should have used white paper. If I go around, everyone else that has the same ordered pair would be what angle here? 2 pi over 3. There's more than one person here, guys. What angle here?
4 pi over 3.
Thank you, 4 pi over 3. And in this space?
5 pi.
Good. These are all the same ordered pair, but again, you look at the positives and negatives to sort out the difference, okay? Last one, the ordered pairs for this middle guy right here with the 4. What number plus or times itself is 4? Right? So 2 is very related to 4. This is going to have a lot of 2's in it. What's the ordered pair for this one? Do you remember? Good. Rad 2 over 2, rad 2 over 2. Okay? And then these will all match up as you go around with those values. Now I'm going to try to use, I don't know, I don't think this is going to show up, but yeah, there's pencils there, and then I have some colored pens in this jar. So if you want to take these, or if you want to borrow one of my highlighters, you can. They're over there too. I'll try to bring some more here. And I think there's just pencils in there. Those are big markers. These are like colored pens. If this might be better for you. You want to take this one? A couple of these to borrow? Okay. So here I'm just going to go with the, yeah, that's all right. Kind of shows. I swear it's a little bit better, but there and there. Okay. Those all match up. And then these ordered pairs are what? What angles are these? I also told you a word for these. What are these angles called? I heard it. Good. Quadrantal angles. And the ordered pair would be what for this spot? I'll put these in red. This ordered pair is? Good. 1, 0. This one is? 0, 1. This spot is? Nice. And here is 0, comma. Good. Okay, so those are all marked up. Perfect. So really what we need to do, big time first and foremost, are how to figure out the sine of an angle and the cosine of an angle. Okay? Sine of an angle, cosine of an angle. If I want sine, normally we would refer to this, opposite over hypotenuse, right? Now, in the unit circle, the reason it's so handy, if I ask you for the sine of pi over 6, opposite over hypotenuse. But what's the hypotenuse for every triangle we make here? 1. So do you have to write the number over anything? No, when it's over 1, you don't have to write it. What's the opposite? How high up is this? 1/2, that's the answer. So if I asked you, what's the sine of pi over 6? Your answer is 1/2. If I ask you, what's the cosine of 3 pi over 4? So here's 3 pi over 4, adjacent over hypotenuse. It's the orange tick mark or the purple highlight. It's very lightly colored, sorry. Adjacent is down here. Hypotenuse is over here. It makes this right triangle that we refer to. And we'll talk more about it tomorrow just because I want to kind of get to the nitty-gritty of this. Adjacent over hypotenuse. This ordered pair is the same as this ordered pair. But what's the adjacent side? This side. But what sign? If it's the x value, it's going to the left. Negative. Negative how much? Negative radical 2 over 2 over 1, which I don't need to write. So the cosine of 3 pi over 4 is negative square root of 2 over 2. So, yeah. So the hypotenuse on the unit circle is always 1 because it's the unit circle. So we made it on purpose 1 so that we could shortcut it and just use the legs of the triangle. And always our hypotenuse will be 1. So sine and cosine are like essentially done by like knowing the circle. Then to do the others, right, the only thing that changes is direction. So your positives and negatives are impacted. So the only thing that can change is the positive or the negative. The dimensions that we're moving on the unit circle to get to these angles, these special angles, will always be the numbers that we called small, medium, and large, essentially. What was small? 1/2, good. What was medium? Rad 2 over 2, good. And what was large? Good. So if you want to know, like, oh, I go over a lot. Who do I go over a lot for? Pink, purple, or green? Who do I move over a lot this way? Large is pink. I move over medium for which one? The purple one. And I move over small for which one? Do you see for green? Small, over, over, over. But what if I want my opposite, my up? Who do I move up small for? Pink. Medium for purple, and large for green. So you need to know how to make the circle with not just the radians, but with the ordered pairs. Okay? Now, I don't want you to try to memorize it. Think of them this way, as small, medium, and large. Medium is always going to be the same number. So can you remember that rad 2 over 2 goes with pi over 4s? Can you make that part of your memory, guys? Can we handle that?
Yes.
What goes with pi over 4s? Which ratio? Thank you, one student. Okay. Can you remember that these other two go together? And then the one is shorter than the other and the other's longer. Short, long, small, large. Over a lot, up a little versus over a little, up a lot. You need to know these, okay? You need to know these. So I'm going to give you a couple to try right now using your own circle. Try to figure out these. Sine of 5 pi over 4. Okay, and this will also be your homework, okay? Cosine of 7 pi over 6. Sine of 5 pi over 3. Cosine of pi. Sine of 11 pi over 6. Cosine of 5 pi over 6. Sine of, running out of room, I should zoom out a smidge. I'll do it next to it. So those 5 there, and sine of 2 pi. Cosine of pi over 2. Sine of 3 pi over 2. Cosine of 0.
Wait, how do we do that?
So you're just going to look now. What was the, that's what we're going to, I'm going to flip over one more time quickly here. But here, where do we look in the ordered pair to get the sign? Let's do the shortcut right now. Look at your ordered pair at pi over 6. Which one gave you the sign?
X.
That's x, that's y. Sine of pi over 6, we got 1/2.
Oh, it'll be Y.
Yep, so the sine of an angle is always the y value. Boom. I'm glad somebody asked. Cosine of the angle is always the, look, we got negative rad 2 over 2, and I was going here. I was like, oh, adjacent. What was I showing you? Which value? The x value. So cosine is always the x value. Do you remember the other day? I was like, remember, x and y in alphabetical order, cosine, sine, alphabetical order. So cosine goes with x, sine goes with y. So if you know the ordered pairs, you essentially know the sine and the cosine. So do we all write this part down? Sine is the y, cosine is the x. I'm going to flip back over to the questions I want you to do. And then these, sorry, it's a little sloppy. I'll put it neater later. I'll do 2 more on here. So sine is of 3 pi over 4, and cosine of, let's say, 2 pi over 3. Okay? So just those examples, you could essentially use your unit circle to do.